So this time around, we want to continue working on functions associated with the token type. And we're in models.go inside the internal folder, inside the data folder. And down here at the very bottom of the file, we're going to write two functions. The first one is going to generate a token, and the second one will authenticate a token. Okay, so let's get started with generating a token. So a func with the receiver of t pointer to token, as expected, so it's associated with the token type. And we'll call this one generate token, which seems logical. And we're going to require nothing more than the user ID, the ID for the user for whom this token is being generated, and that's an integer. And we also want the token to expire at some point in the future. Tokens don't last forever, and we'll call that TTL for time to life. And that's of type time.duration, okay? And it returns a pointer to a token and potentially an error. Now, first of all, let's start creating the actual token we're going to use. So we'll declare a variable, and I'll call it token. And it's a reference to the token type. And I'll populate a couple of its fields. First of all, user ID. And of course, that comes right from the call to this function, the parameter user ID. And the second one is going to be expiry. And that also comes from the call to this function, but we have to, of course, add that duration to the current time. And Go makes that really easy. Time.now gives me the current date and time. And then we add to that the duration, time to life, TTL. So now I have the beginnings of my token type. Now I actually have to make the token itself. And it's really easy. It's going to take us around 8 or 9 lines of code. Go makes this remarkably easy. The first thing I need is some random bytes. So some randomly generated bytes. So I'll declare a variable, random bytes. And I'll assign that using the built-in function make from Go. I'm making a slice of bytes, which I have to spell right, a slice of byte. And of course, the size is 16. And that's important. Make sure you get that number right. Actually, make sure you get everything right. But pay attention to the 16 because we want our token to be a certain length. And that's one of the things we'll verify. So we have the random bytes. Now I'll ignore the first return value, but check for an error when I call from the rand package built right into Go, read. And we're going to read into random bytes. Okay? Now, we check for an error. If error is not equal to nil, then we'll return nil in the error. But assuming we get past that, and we will, I missed an assignment operator up here. That was really sloppy of me. That's assigned the value of a reference to token. Sorry about that. Assuming we get past that, now we're going to populate the token variable we declared on line 323. We're going to populate the token part of that, okay, with base 32 from the standard library using standard encoding. And then we specify what kind of padding we want. And we actually want the constant base 32 no padding. In other words, we know exactly how long this is going to be. And we'll encode this to a string. And what we're dealing with, of course, is random bytes. Okay? That gives me the actual token itself. That's the plain text token. Now I want the hash for that token. So hash is assigned the value of using the built-in package SHA-256. Make sure you get the right one, okay? Not 512. So 256, and the parameter for that is a slice of byte, and all we handed is token.token. In other words, we're taking that plain text token we generated there on line 336, converting it to a slice of bytes, handing it to the function SHA-256, which looks like I missed something there, dot sum 256. Again, don't get the 224, get the 256. I seem to be sloppy today, but we're getting it done. So we're taking that plain text token, converting it to a slice of bytes, handing it to the method sum256 from the built-in package SHA-256, and that gives us a hash, okay? And then we just say token.token hash is equal to hash, and I'm going to convert it from what it is, and you can see here that sum256 returns 32 byte. I'm just getting that down to exactly the format I want, because token hash is supposed to be a slice of bytes, and this will make sure it's nothing more than a slice of bytes. Okay, so we're just converting the type there. And finally, return token and nil. So that generates our token. And as you can see, it's a really short function, okay? So that generates it. Now the next thing we're going to have to do on a regular basis is to authenticate a token. We get a token handed to us by the client. In our case, it'll be a front end written in Vue. And then we have to make sure that token is actually valid. And there's quite a few checks to make here, but none of them are difficult. So we'll declare a function, t, with the receiver t pointer to token. And we'll call this one authenticate token, which seems logical. And this only requires one parameter. And oddly enough, it might seem odd to you, but we're actually going to take the pointer to the HTTP request. And of course, we have that anytime we're in a handler. So we're handing the full request to this function. And from that, or after we deal with it, we're going to return a pointer to a user and potentially an error if something's not working the way that it should. Now, one of the reasons we're handing the full request to authenticate token is on the front end, we're actually going to set a header. And the header has to be called authorization. Exactly that, okay? So we're going to check for the authorization header. So authorization header, which is a long variable name, but I can live with it. And that's assigned the value from our, which is our pointer to our HTTP request, looking at the headers, so dot header, we're getting a specific header named exactly authorization. And it's very, very common for people to misspell authorization here. So make sure you get it right. So we'll do a sanity check here. If authorization header is equal to an empty string, which is what we'll get if it doesn't exist, then we'll return an error. And we'll return nil, first of all, because there is no user. And then we'll just make an error string, errors.new. And we'll give it the appropriate string, no authorization header received, or something like that, okay? So that's our first check. Next, we expect to find in the header, in the authorization header, we expect to find a very specific thing, okay? So let's take our header parts. That's a variable name I'm going to use. Header parts. That's assign the value of, from the strings package, we're going to split what we find in that header. We're splitting authorization header on one space because we're expecting to find the word bearer followed by a space followed by something else. So there should be exactly two things in header parts at this point. The word bearer and then whatever came after the space, okay? Not surprisingly, that's our token. So if the length of header parts is not equal to 2, or header parts, the first index, is not equal to the word bearer, and again spell this right, then we have a problem. So I'll just copy this error message here and paste it in here and change the actual message. I'll just change it to, well, actually I can leave it exactly like that because we still don't have a valid authorization header, okay? But I can put the word in here, no valid authorization header received. R-E-C, spelled that wrong. R-E-C-E-I-V-E-D, that's better. It's always nice to spell things properly. Here I am telling you to spell things properly and I'm misspelling things. Oh well, it's that kind of day. And if we get past these two checks, then we actually have our plain text token. And I'm going to assign a variable named token the value of header parts at the second index, which is of course number 1 since we start counting at 0. So now I finally have my token. Now let's put a few more checks in here. That token, the logic we use to generate it up here in the generate token function, that will always generate a token that's exactly 26 characters long. Let's make sure it is. If len of token is not equal to 26, then I'll paste in that error message. Actually, I'll copy it. I had the wrong thing in there. So I'll copy this error message. And I'll change the actual string I'm passing to it to say token wrong size. Okay? You can put whatever you want in there, but that's the essence of the information I'm trying to convey. Now, if I get past that, I have the correct authorization header. It consists of the word bearer followed by a space followed by a plain text token. That token is exactly 26 characters long. Now I have to try to go and get that token from the database. So I can't call it token, but I can call it TKN. That's what I'm going to call the token from the database. You could call it token model or whatever you want. And we'll check for an error. And of course, all we have to do now is say T from our receiver, get by token, and hand that token. We've already written that function. And we check for an error. If error is not equal to nil, okay, then we can't actually get that token. So I'll paste in that error message, and I'll change it to no matching token found. Okay? But if I get past that, I now have my token. But I need to make sure that token hasn't expired. Make sure that it's still valid. So if, and again, this is easy, from TKN, which is the token model we pulled from the database, its expiry is before time.now, then it's expired. Okay? So again, I'll paste in my error message, and I'll just change it to expired token. You can't log in with a token that's no longer valid. But if we get past that, finally, we're going to have a user, hopefully. So we'll try to get a user from the database. So I'll declare a variable user, and I'll check for an error when I call t.getUser for token. And in this case, I just hand it TKN. Now I can't just do this because it's expecting to find an actual token there. And instead, we just put an asterisk in front of it. Okay, and we dereference it. And now we have the token type that we can hand there. We'll check for an error. If error is not equal to nil, then I'll paste in the error message and change it to no matching user found. But if we finally get past that, we can return user and nil. Okay? So that seems like a lot of steps to authenticate a token, and in fact it is a lot of steps to authenticate a token. We have a very secure token we're generating, so we want to make absolutely certain that when we receive a token from the user, that it is coming with the correct headers, that it has the correct token, that that token is the right length, that we can find that token in the database, that the token has not expired, and then that token is associated with the user. And if we pass all of those things, then life is good. Okay, so now we have 1, 2, 3, 4 functions for the token type. But we still have to write a few more. So let's get started doing that.